The table shows values for a twice differentiable function f, and f is a strictly increasing function. So which of the following must be true? So first of all, we should really look at that term twice differentiable. Twice differentiable means that both the f and f prime are smooth and continuous. Okay, so the derivative function is the f is smooth and continuous, and the f prime is smooth and continuous, which makes the f double prime continuous. Okay, so if the f prime is smooth, the derivative must be continuous. So that's the first thing we should look at and just make sure that we're aware of that. So which of the following must be true? So let's take a look at A. F has no critical points. Well, this term here, strictly increasing, that means that it is always going up, which means that f prime must always be greater than 0 for all points. For f to have a critical point, f prime must be equal to 0. So this is not true. This is in fact true. It cannot have critical points because f prime is not equal to 0. So this is true. Okay, so let's then take a look at part B. Now part B refers to the mean value theorem. It says f prime is equal to 8 for some value c from -1 to 5. So if we take a look at this, where is this value of 8 coming from? It comes from the average rate of change. So if we take a look at the table here, from -28 to 20, we've gone up 48, and from -1 to 5, we've gone up 6. So what that means then is our average rate of change, so the average slope, is going to be the change in y over the change in x, which is positive 48 over 6, which is positive 8. So this is the average slope. So what we're trying to find is at some point where on the graph between -1 and 5, where the tangent slope, or the f prime, is equal to the average slope, which is 8. So this is referring to the mean value theorem. And if I draw this out, because it is smooth and continuous, okay, the fact that the f is smooth and continuous is really important. So this is my f graph. It is smooth and continuous. So that red line represents the average slope, which we calculated to be 8 units per 8 to 1. And if we take a look at this, because no matter how, I've just kind of randomly drawn this, but I'm taking those relative points, I've drawn this graph, and it didn't have to look exactly like this, but this is a smooth graph, and we can see that the way I've drawn it, there's at least 2 points, C1 and C2, where the tangent line is parallel to that secant line, or the average slope line. So this is the mean value theorem. Okay, now the mean value theorem doesn't say that it happens twice. It says it happens at least once, but that is a mean value theorem. So we can say this is true. Okay, and the way we do it is this. First of all, we have to state that f is smooth and continuous, or we'll just say is differentiable, which means the same thing. Secondly, because it's smooth and continuous, okay, we can say by the mean value theorem, there must exist a c where c is between x is -1, it's in the interval, where f prime of c is equal to average slope. And in this case, the average slope is equal to -8. Or sorry, the average slope is equal to positive 8. Okay, so by mean value theorem, this is true. And again, we can see that this is true when we sketch this graph. I've plotted the points. I've kind of sketched a smooth curve through it, and there has to be at least one point where the slope is parallel, the tangent slope is parallel to the secant slope. And then finally, looking at part C, it says here f double prime x is equal to 0 for between -1 and +5. So this is our interval notation. Doesn't mean the coordinate -1 and 5. This is an interval notation from x is -1 to x is +5. Okay, so taking a look at that, where the second derivative, first we can kind of do it a couple different ways. So I'll do it one way, looking at it from the f prime perspective. So here I've calculated the interval, the f prime values in the interval. So for example, between 1 and -1 and 0, we have the change in x, the change in y over change in x, or the slope value, I'm calculating as positive 28. Actually, it's positive 26. Okay, so that slope value is positive 26 when I calculate from -28 to -2, and from -1 to 0. Okay, that slope is positive 26. From 0 to 3, from here to here, the slope value is going to be, the rise is 12, the run is 3, so the slope value is 4. And between 3 and 5, the slope value is going to be, rise is 10, okay, the run is 2. So I get the slope value ends up being +5. So those are my slope values. And what I'm going to do is I'm just going to plot them out. So I've got, positive 24, positive 4, and the +5 comes up a little bit. Now what ends up happening is, for this to happen, this is smooth and continuous. Okay, since it's twice differentiable, it's smooth and continuous. It has to look like this. Well, if it looks like this, that means then that I'm changing my slope direction. The slope of the slope is going from negative to positive. And at some point, the slope of the slope must be equal to 0. So at that point, wherever it is, it could be right at the 4, it could be somewhere else, but at some point, it has to change direction, where it's got decreasing slope from 26 to 4 to increasing slope from 4 to 5. At some point, through the smoothness of that graph, there must be a point where the slope of the slope, or the second derivative, is equal to 0. So this is where f double prime of x must equal 0. Okay, so this is then true. Okay, so there's a second way we can approach this problem, and we can look at it from an intermediate value theorem perspective. So if I take a look at the second derivative, what I can see is that between the positive 26 slope and the positive 4 slope, the slope of the slope is negative. So I can just draw a negative point in here. Okay, so I've got a negative point. I've got, I've shown that it's negative here. And between 3 and 5, it goes from positive 4 to positive 5. So we must be increasing slope, so it must be somewhere here. Now, because it's second derivative, and because it's twice differentiable, it means that the first derivative is smooth and continuous. So the function is smooth and continuous, and the derivative is smooth and continuous. That means then, what that implies is that the derivative of the derivative is continuous. It doesn't necessarily guarantee it's smooth, but it's continuous. So we know that this f double prime graph must be continuous. And if it's continuous, to go from negative to positive, we must hit f double prime x equals to 0. So we know that we can state it this way. 1, f double prime x is continuous. Secondly, we can invoke a theorem. By IVT, we know that f double prime must equal 0 somewhere between -1, and +5. Okay, because we know that somewhere at some point it's negative in that interval, and at some point it's positive in that interval. So we know that it must at some point hit 0 in that same interval. So we have yes to all these. Okay, this is true for all three of these problems.